Hello everyone. In this video, we want to make you familiarized with the buckling and lateral buckling option in CYPE software. So which means here I have the buckling and lateral buckling options. So I was requested by some of our followers that to create a video talk about the buckling and lateral buckling analysis, or let's say lateral buckling options in CYPE and how we can make sure that our buckling factors and lateral buckling factors are set correctly. So in this video, I want to show you the result of CYPE and I want to compare the result with STAAD Pro and SAP 2000. So for this example, first of all, I have this simple frame. So as you can see here, I have very simple frame. And for this frame, so I assign the pin connection. And here also I have the UB section. As you can see here, for the rafters, I have the UB 610.229.101. And here also for the columns, for this both or end columns, I have the UB 610.229.113. And for the center column, I have the UC 305.305 by 97. So it is the first thing, and let me show you the model that I have in STAAD Pro. So here in STAAD Pro also I have the, for the rafter UB 610.229.101. For corner columns, I have the UB 610.229 and 113. And for the center column, I have the UC 305.305 by 97. Similarly here in SAP 2000 also I have the sections. Okay, for the rafters I have the UB 610.229 and 101. And for the corner columns, I have the UB 610.229.113. And here I have the UC 305.305.97. So the situation for the sections are similar. And also for the loads, so in CYPE, so I apply the load for the dead load. Here I have 1 point load at 3 meters, and here I have the distributed uniform distributed load at 5.2 kilonewton per meter for the rafter. And for live load, I have point load of 26 apply from here, so at this end at the apex up to here it is 3 meter, and I have the uniform member load at 2 kilonewton per meter. And also for the wind, I have this wind load, so here I have 3 and here it is 6 kilonewton per meter. So similarly in STAAD Pro I have also this loading. So if I go to here, I have this load. Okay, and if I go to the live load, so here I have the live load, 2 kilonewton minus 26. And also for wind load, I have actually, this case for wind load. Similarly, in SAP 2000, I have the similar load. So after running the analysis in STAAD Pro, if I go to STAAD Pro and if I want to look at the utilization ratio, so here I have the utilization ratio for the rafter as 21.5, so which is really overstressed, and here I have 3.01 for corner columns, and for center columns I have 0.976, which is passed. And for setting the code, so if you look at the design parameters, so here I didn't assign anything, just I want to design based on the code. So it is the thing that I am considering in this video. Similarly for SAP 2000, so if you go to the design data, so here I have the BS5950, and from here, so just I have the default value. So I'm not actually applying any customized value for this design, just to make sure that the result that you are getting from CYPE is acceptable and at least it can be comparable with SAP 2000 and STAAD Pro. But here in SAP 2000, if I go to, let's say, design the section, okay, so here I can see that for the rafter, the utilization ratio is 22.1, and here it is almost 3, 2.93 something, and here it is 0.98, which is very close to a STAAD Pro result. Again, if I go back to here, so you see here I have the, for SAP 2000, here I have 22, and here is almost 3 in SAP 2000, and here is very close value 0.98 in SAP 2000, and here we have almost again 0.98. So no problem about the result for SAP 2000 and STAAD Pro. But once I'm coming to CYPE3D, if I want to check the result, okay, so for the corner columns, I have 76%, so which means, you know, this both columns are passed. And if I come to here, so the utilization ratio is 0.19, so which is really over design. Okay, but in SAP 2000 and STAAD Pro, so it shows us utilization ratio is 0.9, almost 0.98, so which means it's really in the critical situation. And here in SAP 2000 and STAAD Pro, I had the utilization ratio of 22, okay, but here I have about 1.46 or 146%, which is completely different from the result that we got from SAP 2000 and STAAD Pro. So what is the problem? If I look at the buckling factor, so here you need to pay attention to these two options. Okay, so once you are adjusting the buckling, so it is not only, you know, buckling, so also you need to adjust this buckling, lateral buckling as well. So for example, here by default, if I go to here, you see if I click on these two rafters, and then here by default is 0. So if you hold your cursor at the top of this, so which means do not take buckling into account. Okay, so by default actually we have this, and if I go to the corner columns, so here again by default is no buckling is considered, and for center column also no buckling is considered. So it is for buckling. Let's go to lateral buckling. So here also if I go to the rafter, so here I have the let's say no buckling effect. If I go to corner columns, no buckling effect, and here also no buckling effect. So how we can set the buckling correctly to get the result? Because right now we have two results from two different software, and so it is a good chance for us to compare the result of CYPE3D with those two solutions, which is SAP 2000 and STAAD Pro. Guys, always please pay attention to buckling. So right now here, whatever actually, you know, I have, first of all, I can consider them as for lateral buckling. So I will select all of them, okay, as simply supported bar. Okay, so I will consider them as simply supported bar and then accept. So why I'm considering them as simply supported? So here I know actually here it is the rigid connection. Okay, so here I know that it is rigid connection, but the behavior that CYPE is taken into consideration is actually, you know, a simply supported bar or element. So that's why, based on my experience, so you can take this one as simply supported bar. So it is the first thing that you need to do with lateral buckling. Okay, so I did with lateral buckling. For buckling, so I will also select all of them. Okay, so here I will select all of them as let's say one, or let's say here I have the simply supported and simply supported. Okay, and then accept. So let's see if I run the analysis, what kind of result I will get. I will run the analysis, and from here, if I go to check element, so right now here I have the utilization ratio for the rafters is 20.8, which means almost 21, the utilization ratio. Okay, or if you want to take it as you know, as shown, which is 2083%, the resistance or utilization ratio. But if you want to read it in the format of SAP 2000 or STAAD Pro, so it is 20.8, which means 21. okay, which is again, really close to SAP2000 result and STAAD Pro result. So here, similarly for this rafter, so you can see this. And for the corner columns, so how much is that? It is 2.94, so which means again really close to 3. Okay, so we have no problem and the results are very close. And here also the result is very close. Here also we have the 2.94. Okay, but if I look at here, okay, so what I have here, so here I have 0.93, so which is correct again. It is really close to SAP2000 result and STAAD Pro result. So guys, in this video you learn how to set the buckling factors and lateral buckling factors for the frames that you have. So it is very important, and in SYPE, so you need to pay attention to the buckling factors and lateral buckling factors, otherwise your result will be really far away from the thing that you expected. Okay, so in this video we wanted to share this important thing and important options for buckling and lateral buckling factors with you. Hopefully you enjoy this tutorial, and please stay tuned with us for more updates and tutorial. If you have any comment, if you have any request, please let us know in the comments below the video, and we'll come back to you soon. Have a great day and stay safe.